Hi friends, welcome back to Edutech Africana. My name is Mukong Tangwa, and in this video I'm going to be showing you how we can use components from our science kit to produce rays of light and how we can test the laws of reflection of light. In our last video we showed you how to prove that light travels in a straight line. So if you have not seen that video, please go back and check while we get ready for this. In this exercise, the requirements we need from our science kit are: we need this simple DC circuit, which consists of a battery pack, a switch, and a light emitting diode, which will serve as our source of light. We also need a light stand to hold our light in place. We need these two plastic plates. One plate has a slit, just one slit, and the other plate has 3 slits. We need these plate holders to hold our plates vertically, and we need this plane mirror as our reflecting surface. We equally need these requirements that are not found in our science kit. We have a ruler, a protractor from the math set, and a white sheet of paper, and of course a pencil. So to begin with, when you put on the switch, the light comes on, which shows that our DC circuit is complete and we have a source of light. Then we are going to mount this light emitting diode on our light stand. And just know that the light stand has 2 holes on it. There is one hole that is 3 centimeters from the base and another hole above. So when we want to produce rays of light, it's preferable we use the hole above, and I'm going to show why. We just had a disconnection at this level, so we just connect it. Okay, so our light has been mounted on the stand. So next we have to mount, let's start with these 3 slits. We use these 3 slits to produce a beam of light. So we mount it on one of the plate holders. One plate holder is enough to hold the plate. We need to mount it on the white sheet of paper. Place it on the white sheet of paper, including the light stand. Okay, let's put on our lights and see if we're going to have the rays of light. When you shift the plastic plate away from the light source, we can see the rays clearly there. Those are our rays of light. So this is actually a divergent beam, and when you shift the plastic plate away from the light source, the beam becomes more parallel, as we can see this way. So we can observe the reflection of these rays by introducing the plane mirror. Let's see. We can see the reflected rays. As I rotate the mirror, the reflected rays of light also rotate. That is reflection at the plane surface, as we can see. So next, we are going to use the single slit to produce just one ray of light and test the laws of reflection. We are going to replace this plastic plate with 3 slits with the one that has just 1 slit. Let us mark our mirror surface with a straight line. So our mirror is going to rest on this straight line, and we can use our protractor to draw a normal to that line. So we align the protractor and we use it to get our normal. You can mark one point here Remember, 2 points are enough to draw a straight line. So that is the normal to the line we have just drawn. This is our normal. So our reflecting surface, which is a plane mirror, can rest on that line. Let us put on the lights. Okay, we can see a ray of light being produced there. Now we are going to make sure we incident this ray onto the point of incidence. The point of incidence is the intersection between the normal and the reflecting surface. Okay, we can see a ray of light now passing through a point of incidence. Now let's bring in the mirror and observe the reflection. We have an incident ray, a reflected ray, and a normal, and they are all lying on the plane of the paper, and that verifies the first law of reflection. Now let's mark 2 points on the incident ray, and we also mark 2 points on the reflected ray. Okay. Now that the points have been marked, we link them together with a ruler. So the 2 points, the first 2 points marked on the incident ray, they are going to give us the incident ray drawn with a pencil, and of course it should carry an arrow indicating the direction of the ray. And then we mark the 2 points on the reflected ray to form a pictorial representation, and we indicate the arrow moving away from the reflecting surface. Okay, now we can represent our reflecting surface as we see there. Now the angle between the incident ray and the normal is the angle of incidence, and we also have the angle of reflection between the normal and the reflected ray. Now let's do some measurements. We align our protractor. The origin of the protractor should be at the point of incidence, and the 90-degree line should coincide with the reflecting surface, while the 0 line coincides with the normal. As we can see there, the 0 line should coincide with the normal. Okay, so with this arrangement now we can measure the angle of incidence. So we see 10, 20, 30, but the exact mark is at 29. So the angle is 29 degrees. Now let's measure our angle of reflection. We do the same. There's 0, 10, 20, 30, but the line passes through 28. So the angle of reflection is 28 degrees. The slight difference in the two angles is as a result of errors either from the experimenter or from the equipment. And since 28 is very close to 29, we still conclude that the angle of reflection is equal to the angle of incidence. Thanks for watching this video in which we produced rays of light and tested the laws of reflection. Please like and share this video so that many other people can see it. And don't forget to subscribe to this channel so that you can see more videos like this from ours. You can contact us for your science kits to use at home or in school using the details in the description box.